Hey YouTube people, today we're going to be testing AMD's FSR technology but inside VR today and see if it's something that it can improve your frame rate, and if it does improve your frame rate, at what cost. We'll try to answer that question in this video. Rendering 3D games is one of the most demanding things your GPU has to do, and with higher and higher resolution displays it becomes increasingly difficult for the GPU to keep up. It's kind of a magnitude issue. The more X and Y that you add to a resolution, it actually is exponentially growing on the interior of the area of the pixels that need to be rendered in the center of that image. This is why software engineers have gotten creative in the way that they utilize the GPU to push image data to those high resolution displays. NVIDIA's pushed DLSS, an AI-based upscaler that uses machine learning to render a game at a lower resolution, which is easier on the GPU, and then intelligently upscale that image in a way that makes it least indistinguishable from an image that was rendered at the full resolution in the first place. The net effect is that the GPU can push higher frame rates at higher resolutions than it could using traditional methods of rendering every single pixel. AMD has followed suit recently and has developed a similar technology called FSR. While it uses a different approach than DLSS, the intent is the same: render the game at a lower resolution and use creative upscaling to push higher resolutions at quicker frame rates than the GPU could do using traditional pixel per pixel methods. So if you thought gaming at 4K was demanding, imagine VR setups which not only are pushing more pixels than 4K, they are also doing it per eye. Couple that with the fact that maintaining high frame rates in VR is necessary to avoid making people feel sick from their experience, and it sounds like these upscaling technologies and virtual reality might be a match made in heaven. NVIDIA has announced DLSS for several VR games, including No Man's Sky. And while AMD may have future plans to add official support for FSR inside VR games, luckily their work is open source, and aspiring modders have taken care of this for us already to use in most Steam VR games. F. Holger is one such modder, and I'll include a link to his GitHub package in the description. That's what we'll be using today to take a look and see how it affects our performance in a virtual reality game. First, let's see how to install this mod in something like Fallout 4. Alright, so let's take a look at how to install this thing. You should be able to find the link in the video description, but it's right here on this GitHub site. And once you go there, you go to the releases area and download the OpenVR FSR zip that's in here. It may be a different version than this by the time you're watching this video, but we're going to go ahead and download that, and you're going to take your zip file and you're going to extract it, and then you'll see inside here you have two files, openvr_api.dll and a config file. Now I'm just going to copy these right now, and because you're going to put these in place in your game folder. The game I'm going to be working with is Fallout 4, so for me I'm going to go to my Steam directory, and then inside Steam, this is most likely for most people in C, program files, x86, and then Steam, but for me I have my Steam library on a secondary drive. So we're going to go into Steam, Steam Apps, and then Common, and then you're going to go into Fallout 4 VR. Now once in here you're going to find a file right here. It is openvr_api.dll as well. You don't want to just straight up copy right over this, because then you would lose your existing default file. So what you're going to want to do is select that file and rename it to original. And now that you've done that, you can take your files from the zip you downloaded and paste them into this folder. Now the second thing I'm going to do is open up this config file and kind of let you take a peek at it with me. So inside here, we've got some different options for FSR. Now, here's the AMD presets, 0.77, 0.67, 0.59, and 0.50 for ultra quality, balanced, and performance. And that's the render scale. That's basically if you are at, say, just for example, a 1080p resolution, whatever 0.77 of that is your new reduced rendering resolution, and it will upscale it to 1080 when you put it there. So I think to start out, especially since I'm running a pretty beefy machine, I'm just going to use the ultra quality setting and see what type of results I get for now. If you're on a weaker computer, and I'm gonna look at this on a much weaker computer. I plan on making a video on how to optimize your VR performance on a GPU that's not quite up to snuff, and FSR is going to be a part of that. So stay tuned and subscribe for that video coming up. But the other thing you can do is adjust the sharpness. The sharpness ranging from 0.9, or it goes from 0 to 1, but 0.9 is a pretty good place to start, and somewhere between 0.9 and 1 is maybe where you want to be. This radius setting is really interesting. The radius setting lets you choose how much of a circle inside of your window you want to actually apply FSR to. Now, what this means is you can basically let the edges of the image be upscaled using bilinear filtering rather than the true FSR, which is a little bit less overhead heavy, which means if you only want to have the good sharpening and upscaling method done, you could go as low as 0.2, and that might just be a smaller circle right in the center of your vision point, and if that's all you care about, you could play with this to get a little bit better performance. But I'm going to leave it at the default of 0.5 here for now. So those are some of the little adjustments. So if you wanted to go quality, you would change this value to 0.67 here if you wanted. But I'm going to leave it at 0.77 and take a look and see what that looks like in our Fallout 4 testing. So I'm going to save that, and I'm going to reload up the game, and we'll take a look. So there's two things I want to look at as we go through this and apply FSR to our game. First thing I want to look at is how much does this affect frame rate? Does it really give us a boost? Because if there's no boost, why reduce your image quality? And then B, how much does our image quality get affected at different levels? So we'll look at it at their high quality and their performance, which is, performance is a code name for not as good image quality, but should have the highest frame rate. So first, let's look at the frame rates and see if we get a boost by using this technology. So along the top, you can see native rendering, and we have a frame rate counter over there on the left side of each of these screens. And at native resolutions without FSR applied, it tended to do pretty well, but dipped into the 70s and 80s occasionally, where FSR, only running at 77% of the regular resolution, then upscaled, tended to stay above 120 frames per second most of the time. So yes, there are some performance gains here, but also the other thing was there is a little bit of sharpening that happens with FSR, which I actually like. I applied sharpening mods anyways in SteamVR, so that's actually good. This is built in as well. So now if we look at this thing in performance quality, that you can see performance is running at half resolution. So if it was 1080, divide that in half, it's 540. So obviously your performance should be much better here, and it is. It was basically locked at 144 frames per second. So definite performance improvement, but how did that affect the image quality? We're going to look at that next. So in order to show the image quality differences, it's necessary to do this through the lens because you probably saw the rendering window on the desktop actually shrunk every time we applied more and more FSR. It got smaller and smaller, which means you actually have to see it through the lens to see what the differences are and what the image quality looks like. I'm going to show those on the display and comment on them as we look at them together. Okay, so these are the through the lens videos comparing native and FSR ultra quality. And FSR ultra quality looks pretty good. You can see a little bit of shimmering around the edges, just slightly. However, I don't know if you would notice at all, really. I mean, in a blind taste test, to coin a phrase, I don't know if you'd actually be able to notice easily. Looking at the performance quality, you can see quite a bit of artifacting, especially around the edges of things like that lamppost right there. But the texture qualities, when you're looking right at it, look pretty good. It does a good job of upscaling. You can see the rocket seems to have a lot of the detail preserved, or at least apparently preserved, with their upscaling method. So frame rate is super smooth in there, though, so it's good to have the option to have it smooth, but you can definitely see some issues with that performance method of upscaling. So I've had a chance to play with FSR technology in VR using this community mod for several days, and I have a few takeaways that I want to leave you guys with as we've looked at this. First thing is, open source is awesome. It's awesome that AMD released this open source so modders could immediately take it and tinker with it and make it available to everyone. The fact that we have modders who can turn this around that quickly and get us out and available to play with is just awesome. My first impression is... So my second takeaway is the FSR ultra resolution setting was almost indistinguishable from native rendering. So to me, that's like, it's almost a no-brainer to apply this if you are having trouble with maintaining certain frame rates. But that brings me to my third takeaway, which is if you, and I hate to be like I'm the PC Master Race guy, but I've got a 3090, RTX 3090, and AMD 5950X in my machine, and with a Valve Index that doesn't have the best resolution out of all the headsets out there, I can pretty much run anything, even at 144. So I was going through game after game after game trying to find something that was dropping frames that I could actually use this thing to get a benefit from, and there was almost nothing out there. So if you got a high-end PC and you're not experiencing like noticeable performance problems, this may not interest you. But the second you update your headset to something like the Vive Pro 2 or the Varjo, which has an incredibly high resolution, or the Reverb G2, my story may have been a little bit different there. So that's my takeaway. If you're already running high-end gear, you don't have performance problems, why mess around with this? But for the majority of people who are running, a low to mid-end GPU, this is great technology. You will be able to get better frame rates without really affecting your image quality. If I put it this way, if you are running your headset at 1600 by 1600 per eye and it was dropping frames, and in order to get a smooth 120 frames per second or something, you had to reduce it to maybe 800 by 800 per eye, and that's the way you were able to hit your target frame rate, that would look pretty bad. But if you use the performance mode FSR, it's still going to look bad, but not as bad as if you just reduce the pixels. The upscaler, it's kind of having your cake and eating it too, because you do get you get the benefits of dropping your resolution without it having it look as dirty and pixelated. So it's actually really good technology for that. And if you noticed, in even on my high-end PC, I could see a case for, like, if you're someone who you're playing Fallout and there's just certain sections of the game that just drop out on you, and you are really sensitive to dropped frames, and you know, if it's running at 60 frames a second or lower all of a sudden in just certain areas, and you're just like, this sucks. Have FSR turned on, and you don't drop nearly as low. You never hit those spiky, laggy areas anymore because you're using this technology. That's a great use case. You can maintain your motion resolution more than your visual fidelity resolution. So there's kind of this sweet spot of technology, sweet spot of where this technology is useful. Because if you have like just a bare bones, like, I mean, it's not going to do miracles. You're not going to be able to take your like Intel HD graphics and suddenly be able to run VR on them, you know, and have any sort of good quality. But if you're one of those kind of mid-range people, you've got maybe like a 1070 or, you know, a 2060, and you're running a headset that's, you know, or even a Quest has fairly high res. Quest 2 has very high resolution even compared to the Valve Index. So you could apply this and basically hit the frame rate and the resolution that you're trying to hit. So it's pretty cool. Like, I think the people who benefit this most are those with those lower to mid-range GPUs, or you have just a headset with a huge amount of resolution. Maybe you're a Pimax 8K user with two 4K displays to push pixels through. I think that's going to be very important in the future going forward. So I think this is pretty neat technology, and you can definitely benefit from it, and it's free. So go check it out. Hopefully this video was useful to you to be able to know how to do it, and give you the right expectation of how it's going to affect your experience as you use your VR headset and play with FSR. So thanks for watching. Please subscribe. We'll have a video coming up soon on how to use a low-end GPU and get as much performance as possible out of it for VR. So thanks for watching. See you later.